Alright, hello. So, you saw a topic, and now we're going to talk about something is called the remainder theorem and the factor theorem. So, before we actually get into the thing, let's start easy first. So, as a recap, we know that a fraction. So, a fraction is something that you have something divided by another thing, and this is a fraction. So when we have a, so we have like when we have a over 3, for example, we have 6 plus 2 over 3, and in this case which is 2 plus 2 over 3. So this is the factor, and this is the remainder. So this 2 is the remainder, and this is the factor. Alright, so now let's start to get into polynomials. So you know that when we have a polynomial fx, well, some polynomial, and I'm gonna briefly explain what's factor theorem and remainder theorem. So first, we have the remainder theorem. So the remainder theorem states that if you have an fx, and if you divide with x minus k, where k is a constant, then the remainder is fk. So in this context, if you look at this, it makes pretty no sense, because if you substitute k, I mean, technically you can substitute a k here, so it becomes 0, and it will be 0 fx over 0, which is pretty much nonsense, but that's not how it works. So here's why. So you see, if we divide, let's say we divide x squared plus 3x plus 1 over x plus 1. Okay, let's start simple. So we have x, and we have x squared plus x. This goes to minus, so we have 2x plus 1. So we have plus 2 here, and this would be 2x plus 2, and we get a minus, and we have negative 1. So what can we write in this form? So we can write x squared plus 3x plus 1 divided by x plus 1 is equals to the factor, which is x plus 2, times the divisor, plus the remainder of negative 1. So the remainder is negative 1. So it's negative 1 over the divisor. So it will be x plus 1. Alright. Wait. Oh wait, this doesn't exist. Alright, my bad. Right. So you see, at first, if you divide something, you will get a factor and a remainder. So if we multiply everything by x plus 1, we can get that x squared plus 3x plus 1 is similar, can also be equal to x plus 2, x plus 1 minus 1. So we just multiply everything by x plus 1, and that's how we get the result. So what can you see here? So you see we divide by 1. So if you substitute x equal -1, so we have x equal -1, and this term will be 0. This term will be 0. This means the whole thing will be 0. So and I'm just going to call this f1. So I'm going to call this fx. So we have f -1 equals to -1. And what's this? This is the remainder. So to generalize this, if an fx, we divide it with x minus k, and this will give us a factor. This will give us a factor, or you call the quotient, and plus the remainder. The remainder over x minus k, right? So to generalize this, we just multiply both sides by x minus k. So we have fx equals to x minus k qx plus rx. So if you want to get the remainder, we're just gonna sub x equal to k. So fk equals to 0 to k minus k qx plus rx. And this term is just 0, so it just cancel out. So we have fk equals to rx. So we have proven that the remainder is equal to the f's of k. So that's the remainder theorem. And what about factor theorem? What about a factor theorem? So this is another thing. So we have a factor theorem. So what's a factor theorem? So it's that if you divide fx by x minus k, and if the remainder is 0, then x minus k is a factor. What do we mean by factor? It means that fx can be factorized with x minus k as one of its factors. It's like 6 can be factorized into 2 times 3, and x squared minus 3x plus 2 can be factorized into x minus 2 and x minus 1. So this is what we call a factor. This is a factor, 2 is a factor of 6, 3 is a factor of 6, x minus 2 is a factor of x squared minus 3 plus 2, and so do x minus 1. So this is the factor. So recall again, if we divide fx by x minus k, and the remainder is 0, then x minus k is a factor of what? Is a factor of fx. So it's a factor of fx. So why? Let's discover. So now let's say we also have the same thing. So we have fx divided by some x minus k, and this will be equals to some quotient plus the remainder. So now we're gonna multiply both sides by f minus k. Okay, so now since fk equals to rx, so if rx equal to 0, so when rx is equal to 0, then this means that our remainder is 0. So fk is 0. So what do we call if you substitute a value to a function and equals to 0? Yes, this is called a root. So k is a root, or we call it a solution. So k is a solution to fx. So that's why for example we're gonna do x squared minus 7x plus 12, and we're gonna test the root, and we're gonna test the root of this. We're gonna find the root without actually factorizing, and we're just gonna substitute f equals to 3. So what's f3? So we have 3 squared minus 7 times 3 plus 12. Well, this is 9 minus 21 plus 12, which is 21 minus 21, which is 0. So we get that. So since f3 is equal to 0, so this means what? 3 is a root. Or for another example, x minus 3 is the factor of x squared minus 7x plus 12. So let's say I don't know the another factor and I want to use the long division. You can do that. So we're gonna divide x squared minus 7x minus 12 with x minus 3, and we're gonna multiply. So we're gonna do x. So this will be x squared minus 3x minus 12. Minus 3x. So negative 7 minus 3 will be negative 4x, and the minus 12 will be get down here. Wait, this is plus. Where's this plus? This is plus. Alright. So now we're gonna put negative 4 here, because negative 4 times x is negative 4x, and negative 4 multiplied by negative 3 is positive 12. So you get the remainder is 0. So what do we call the remainder? The remainder is 0. So this means that x minus 4 is a factor. So this is a factor. And we have 0 as a remainder. So it's like the same thing. So it's like if we divide 50 by 2, so you have 2 here, 2 times 2 is 4, and we have 10. and 5 times 2 is 10, and you get 0. This means that 50 is divisible by 2. So it's the same thing. The same thing implies to here. So if 50 is divisible by 2, then the remainder will be 0. So if x squared minus 7x plus 12 is divisible by x minus 3, then x minus 3 will be a solution. Or in other words, yeah, so this is an example we use in when the remainder is 0. Yeah, I don't think this is correct, but you get it. You know what I mean. So, all right. And since we know that another factor is x minus 4, so therefore we can write that x squared minus 7x minus 12 is equals to x minus 3 and x minus 4. And that's it. So we're going to do a small exercise to see that whether we can use the remainder theorem. So one thing about the remainder theorem is if you have a polynomial, so if you have a n power polynomial, so let's say fx, you have some x to the nth as highest power, n is highest power, and the remainder, let's just call it Rx. The remainder will be x to the power n minus 1. And it's going to continue to x power n minus 2 plus x power n minus 3 plus dot 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 and all the way to 1. And don't forget, there's a constant here, constant here, constant here, all the way to constant here. I don't even know what numbers this is or what letter this is. I'm going to call it Z. So yes, so this is, so for example you have a fx, you have a fx of x cubed minus 3x squared plus 1. So what's the highest power remainder? So the remainder will be in terms of ax squared plus bx plus c. Why? Because you have a cubic, and if you divide the cubic by, so if you divide a cubic by anything, by any quotient, for example, you will get a I think my explanation is quite wrong. So I think it means that we are dividing by fx. Alright, so I'm sorry about the mistakes. Let me clarify again. Okay. So if we dividing by, so if we divide by, we're gonna divide our function by fx. So we have x power n plus something, and where n is the highest power, then the remainder will be in terms of ax power n minus 1 plus bx power n minus 2 for something. So let's say we have fx divided by x cubed plus 2x squared plus 1. So what could the remainder possibly be? So what is the So what the remainder could possibly be? So our remainder, it can be a constant. Oh wait, can be a constant. It can also be a linear. Can also be a quadratic. Yeah, it can also be a quadratic. So it will be a constant. It can also be linear. And it can also be quadratic. So this will be our remainder. As you can see, we're dividing by x cubed over here. So if we're dividing by x squared, it's like x squared plus 2x plus 1. So the remainder can be in terms of linear and constant. Can be a constant and a linear. As long as the remainder doesn't, as long as the highest power of the remainder is always less than the divisor. So we know that. So we know that highest power of remainder will always less than. Oh wait. Will always less than the highest power of divisor. So this is a very important thing, this is a very important thing to remember, because we're gonna learn and we're gonna use this and we're gonna apply this after we're gonna do our first partial fraction problem, which is separating brackets. But now we're gonna focusing on remainder theorem and factor theorem for now. So let's say we have fx. So if fx is a polynomial, so we know that I'm gonna say if fx divide by x minus 3, and let's say the remainder is 2, and for the same thing, so the same fx, I divided by x minus 5, the remainder is -4, for example. So what would the remainder would be if fx divided by x minus 2, x minus 3, x minus 3 times x minus 5? So what will the remainder be? So as you can see, this is we divide something by linear, the remainder is constant, and we divide something by linear, the remainder is constant. So if we divide a quadratic, the remainder will be linear. So this is a very huge hint we just did just now. So now I'm going to show you how to do this question. So first, we know that from the remainder theorem, we know that when fx is divided by x minus k, then fk will be the remainder. So how are we gonna apply this to this? So now we know that what is the remainder of a quadratic? So we know the remainder is x plus b. So we're gonna solve for a and b. Because we already know that fx divided by this x minus 3 and x minus 5, we will get some constant, some function x plus b, where a and b are constant, and we're gonna find it out. So the first case, we know that the remainder will be ax plus b. Right, so a very huge thing over here. So now we have ax plus b, and this will be equal to, so this will be a remainder. So this will be equal to fk. So we know that fx plus b equal to fk. So how many values we have for fk? So we see we have 1, we have 2. So you see this is, so we know that f3 is 2 and f5 is -4. So we know that f3 is 2 and f5 is -4. Why? I'm using the remainder theorem. So you see if fx is divided by x minus 3, then f3 will be 2. It's like fx equal to some x minus 3 quotient and plus the remainder. The remainder is 2, so this is the remainder. So if f3, this term will be 0, so it will be only 2. So that's why. A quick recap. So this is enough for us to solve for a and b. So I'm going to substitute our x to here. So for the first equation, we have f3 equal to 2. So f3 equal to 2. So this will be the first equation. And we have f5 equal to -4. This will be the second equation. So as you can see, this is just a simultaneous equation in 2 variables. So let's go ahead and do a 2 minus 1. And then we will eventually get 2a equals to -6. Therefore a is equal to -3. And from here we can solve for b. We're just gonna take one of the function. So we have 3a plus b equals to 2. And with a equal to -3, we have -9 plus b equal to 2. D will be equal to -11. So therefore, the remainder, I'm going to write it completely. So when fx divided by x minus 3 and x minus 5, the remainder is ax plus b. So which is -3x minus 11. So this is how you find the remainder. Even though you don't have fx, you don't have the quotient, all you need to do is you just need to remember that if you divide, the divisor is a polynomial. If the highest power of 2, the remainder will always have a highest power of 2 minus 1, which is a linear. So I hope you enjoy it. I hope you learned something today. And if you're confused, you can feel free to ask me. And I'll see you next video. So goodbye. Never stop learning. And we learn to study. We're not here to memorize formulas. We're here to understand. And by your instincts, I believe it's the most powerful thing. So goodbye.